Like all through penetrations, heating, ventilating, and air conditioning ducts that penetrate smoke and fire barriers must also be sealed, unless a smoke or fire damper is present and properly installed. In this case, additional sealing is unnecessary. But where a damper is not present, the duct penetration must be sealed with fire stop or smoke sealing materials. In this video, we will discuss how to determine what products and methods should be used to properly fire stop non-dampered duct penetrations. When HVAC ducting penetrates fire barriers, a smoke or fire damper is generally required. In the presence of heat and/or smoke, this device is designed to close and stop the flow of air through the duct. Without a damper, that airflow, combined with elevated pressures created in a fire, would draw the products of combustion through the vents into these ducts, spreading toxic smoke and superheated gases throughout the building. A fire damper is designed to stop smoke and fire from spreading internally through a duct, and when installed properly, additional fire stop sealant is normally unnecessary. In special cases, building codes permit ducts to pass through fire barrier walls without the protection of a damper, such as when a duct passes horizontally through a fire compartment without venting into it, or in the case of grease or chemical exhaust ducting. In cases where no damper is present, fire stop products are required where the duct penetrates a smoke or fire barrier. As with any other through penetration, it is as important to observe all parameters of the UL system when sealing duct penetrations. Packing material, such as backer rod or mineral wool, is sometimes required and often helpful in permitting the fire stop sealant to span large annular spaces. The sealant itself must be installed to the proper depth and tooled. Depending on the type of duct being installed, a UL system may require more than just sealant and packing material to complete the fire stop process. The reason for this is because, unlike plastic pipe, which melts and burns away gradually in a fire, or metallic pipe, which keeps its shape even at high temperatures, the flat spans of rectangular duct deflect quite rapidly at a certain temperature. This creates an immediate gap that even intumescent sealants that expand when heated, cannot overcome quickly enough, creating a breach in the fire barrier. Therefore, flat spans must be braced to prevent this deflection. On square and rectangular ducts, this means that reinforcing steel angles of a specific gauge must be anchored on all four sides of the duct to prevent this deflection. This bracing is required on both sides of the wall. While attaching reinforcing steel angles is a critical step in preventing deflection, it is also important that the angles are anchored only to the duct and not to the wall. Fastening the angles to a fire barrier would anchor the duct to a wall and would restrict its ability to move freely through the opening during expansion and contraction cycles. This would also disregard prescribed industry guidelines. Since round and spiral duct have no flat sides and cannot deflect, reinforcing angles are unnecessary. Flat oval duct, however, does have two flat sides, both of which must be braced with angle. When the duct is externally insulated, the combustible fiberglass blanket itself must also be considered. In this case, a layer of intumescent wrap strip may be required and must first be inserted into the annular space and held firmly in place with 2 layers of foil tape. Next, a bead of intumescent sealant is installed to finish sealing the opening. Reinforcing angles are unnecessary in this case because, as the fire burns away the fiberglass blanket, exposing the bare steel on the hot side, the wrap strip is able to expand inward sufficiently and prevent the blanket on the cold side from burning. The combined effect of the sealant, the wrap strip, and the protected insulation on the cold side allow this particular UL system to pass without steel angles, regardless of the deflection. In the end, however, remember that the requirements of each UL system dictate whether or not steel angles are necessary. Now, occasionally, a duct with a fire damper may be encountered where light can be seen coming through from the other side of the wall. While the damper itself should prevent a fire from passing through the duct internally, clearly the gap is a path that will permit the movement of smoke, gas, and flames externally. Now, if the damper had been installed properly, this path wouldn't exist, and consideration should be given to removing and reinstalling the damper properly. Where this is impossible, or when an authority having jurisdiction requests it, it may make sense to create a smoke stop in this gap, provided that the following conditions are observed. First, written authorization from the damper manufacturer is needed, permitting an external smoke seal to be installed around their damper. This is to ensure that the damper warranty is not voided. Second, the external seal must be made with a non-intumescent fire stop sealant. In a fire, the intumescent sealant will expand with heat and may deflect the light gauge steel inwards, preventing the damper from closing properly and further jeopardizing the compartmentation. Third, because ducts expand and contract, the sealant should be highly flexible, such as fire stop silicone or a smoke barrier sealant. Finally, since there is no third-party testing, this option should only be considered when requested and accepted by an authority having jurisdiction. Your first choice should be to remove the damper and reinstall it properly. Properly sealing duct penetrations is not difficult, but does require some effort to research the proper installation requirements. One useful tip to help speed the time needed to do this work is to standardize around certain UL systems. This way, you can memorize the specifics and avoid researching each and every opening that you encounter.